Okay, so in this video, we are going to look at how to convert an epsilon-NFA to a DFA. Okay, for converting an epsilon-NFA to a DFA, we have already seen how to convert an epsilon-NFA to an NFA, and we also have already seen how to convert an NFA to a DFA. So what we want to do is very straightforward. We can convert an epsilon-NFA to an NFA, and then we can convert that NFA to a DFA. So that's going to be very straightforward. And remember, this process of converting an epsilon-NFA to NFA is called Thomson's construction. This is called Thomson's construction. Okay. So these are all some, the name of the methods which we are going to use. And the conversion from NFA to DFA is known as subset construction. Okay, so you have to remember this because you may be asked what is a subset construction or what is a Thomson's construction. Okay, so applying whatever we have learned till whatever we have learned till now, we can actually do this. Okay, so this is going to be very easy. You can convert an epsilon-NFA to an NFA and then an NFA to the DFA. So this process we are very aware about. And now there is another method of converting an epsilon-NFA directly to a DFA. Okay, so we are interested in looking that direct conversion method. So if you are given with an epsilon-NFA, without converting it to an NFA, we can actually convert the epsilon-NFA directly to a DFA. So we are going to look at that method in this video. So you can see that this is the epsilon. This is an epsilon-NFA. So this is the very same epsilon-NFA which we have used in our initial examples. So this epsilon-NFA accepts strings having pattern AB, AB, AB. Okay. So this is something which you have encountered earlier. So what we are going to do here is that we are going to directly convert this epsilon-NFA to its equivalent DFA. So for doing that, what we need to do is that so if you look at the starting state here is Q0. Okay, so check the epsilon closure of Q0. So in this case there are no epsilon closure. In the epsilon closure of Q0 there is nothing else, other than Q0. Okay, so there is no other outgoing edges going with an epsilon transition. So the epsilon closure of Q0 here is Q0 itself. So our starting state, or this is how we are going to do this. We are going to identify our starting state as the epsilon closure of the starting state given in the epsilon-NFA. So in this case, in this example, if you look at the epsilon closure of the starting state, which is Q0, this is just Q0. Okay. So our starting state is also going to be Q0. Okay. So when we convert this, our starting state is also identified as Q0. Imagine if the epsilon closure of Q0 was, say, Q0 Q1. Okay. So what we will do is that we will make the initial state, the starting state of the DFA as Q0 Q1, right? So Q0 Q1 is represented as a single state. Okay, so in this example we don't have such a case because we have so our epsilon closure of Q0 is just Q0. So our starting state is also going to be just Q0. Okay. So this process of identification of the starting state is very important. So what we are actually going to do here is we look at the starting state of the epsilon-NFA given and take an epsilon closure of that. Okay, so if you're getting a combination of states like Q0 Q1, then you're going to combine them and call it and make it as your starting state. Okay, so since in this example we are looking at the epsilon closure of Q0, we got only Q0. Okay, so that our starting state is also Q0. Now what we can do is that we can create a transition table. Okay. For representing the state transitions for the expected DFA that we are going to construct. Okay, so let me make a transition table. So let me fill in this transition table one by one. So we have already identified our starting state as Q0. So let me start with Q0. And we have to look at the transitions from the epsilon-NFA given. So Q0 on A, we are interested in finding Q0 on A. So we know that Q0 on A goes to Q1. Okay, so that's only transition available. So you can write it as Q1. So what about Q0 on B? Okay, so if you look at Q0 on B, there is nothing defined. Okay, so remember, very importantly, if there is nothing defined, then it is going to a dead state. So we can actually represent it using the null symbol. Okay, so I can say just a null symbol. Okay, in some of the textbooks they notate it with a set also. Okay, so I'm just using a null symbol. I'm not using brackets here. Okay, so to make it very simple. Okay, so so remember, whenever you don't have a transition defined, for example, in this diagram, the transition of Q0 on B is not defined. So in such a case, you're actually going to a dead state in your DFA. Okay, so that's represented as a null symbol here. Okay, so even you can represent it as QD. Okay, so instead of representing it as using a phi symbol, you can actually represent it using QD, where QD stands for a dead state. Okay, so that will make more sense. Okay, so anyway, let's go with the flow. I'm just showing it as a phi symbol to convey that it's a dead state. Okay, now looking at the transitions. Okay, so we are getting a new state here. We are getting a new, all the two states that we have got, both of them are new to us. Okay, so it means so upon transition of Q0 on A, we got Q1. That's a new state for this table. And similarly, we got a dead state. That's also a new state for us. So we will have to define transitions for both of them. So let's start by defining transition for Q1 initially. So if you look at Q1, okay, if you look at Q1's transition on A is again not defined. So it's also going to be phi. So what about Q1's transition on B? So look at here carefully. So if you look at Q1, by just having B, we can reach to Q2. So Q2, and so if you're putting B epsilon, if you're applying B epsilon, you can also reach to Q0. Okay, that's very important. So the transition of Q1, upon B is going to be Q2 and Q0. Okay, so I'm just combining them and calling them as Q2, Q0. Okay, so this is going to be very important. So you have to look at combinations. So you're getting a new state called Q2, Q0 here. Okay, so again, we have not written the transitions for the dead state. Okay, so this dead state is pending here. So we can write it actually. So we know that whenever we get a dead state, okay, we are going to write all the transitions back to the dead state itself. Okay, so we can close our eyes and write phi here, because all the transitions from a dead state goes to the dead state itself. Okay. Then what we are left with is we have to define the transitions for Q2, Q0 now. So if you look at Q2, Q0 and define the transitions of A and B. So let's start by looking at Q2, Q0 on A. Okay, so Q2 on A, there is nothing. Okay, so let's write it here. Q2 on A, you cannot reach anywhere, so it's going to be phi. What about Q0 on A? Q0 on A gets you to Q1. Okay, there is no other possibility. Okay, so this is going to be a combination of null and Q1, which is nothing but Q1 itself. Okay, so you can write Q1 here. And what about Q2, Q0 on B? Q2 on B, there is nothing defined. Okay, so Q2 on B, there's nothing defined. That's null. And what about Q0 on B? Q0 on B, Q0 on B is also nothing. Okay, so there is nothing defined on Q0 on B as well. So that also is going to be 5. So this totally will give you again 5. So what you are going to get here is again 5. Okay. So this is the again in this row there is no new states. Okay, so if you look at the transitions here, so we have already written the transitions for Q1. We have already written the transitions for 5. Okay, so we can stop now because we are not seeing any new states from here. We can stop here. Okay, so once you stop here, then it becomes very easy. The idea here is that the only thing that need to be only thing that you need to be very careful is that whenever you have a dead state, you are representing it with a phi symbol. Okay, you can invariably use QD also whenever you want to make use of convey the meaning of a dead state. Okay, so while we are drawing this diagram, we can either use the phi symbol or QD to represent that particular state. So let's now draw the diagram based on this transition table. Now, before actually going to draw the DFA, we have to identify the final state also. So looking at the epsilon-NFA given, we can identify that Q2. You can see that Q2 is the final state here in the given epsilon-NFA. Okay, so whichever the states that contain, so the states which contain Q2 are going to be the final states of the DFA that we are defining. So looking at these states, Q2 is present only inside Q2 Q0. Okay, so again Q2 is the final state in the given epsilon-NFA. Okay, so we are going to scan through this table and the states which contains at least one Q2, okay, will be all such states will be all such states will be the final states. So in this example, we have only one like that. So which is nothing but Q2 Q0. So we are going to mark Q2 Q0 as a final state here. Okay, so Q2 Q0 is going to be your final state. Now we are all set to draw the DFA for this. So let's actually draw it. So we start with a Q0, right? And on A, we are going to Q1. So if you get an A, you are at Q1. If you get a B, you are at a dead state, which is represented by phi. Okay. So you'll be going to the dead state. And remember, this can, instead of calling it as a phi, you can also call it as a QD or whatever the name that you want. This is just indicating that this is a dead state. And we know that, let's draw it one by one. This is the transition for B from Q0. Okay, now we are interested in looking at the transitions from Q1. Okay, so if you look at the transitions on Q1 on A goes to again goes to the dead state. Q1 on B goes to Q2 Q0. Okay, so if you get a B from Q1, you're going to Q2 Q0, right? Now I have to draw the transitions from Q2 Q0. Okay, so from the transition table, you can see that Q2 Q0 on A is going to Q1. You can see it here. So Q2 Q0 on A goes to Q1, and Q2 Q0 on B goes to the dead state. So we can actually represent it here. So Q2 Q0 on A goes to Q1. Q2 Q0 on A goes to Q1. So you have to be very careful in this. And Q2 Q0 on B goes to the dead state. Okay, so we have to mark the final state. Remember, Q2 Q0 is our final state because it contains Q2, which was the final state in the given epsilon-NFA. Okay, so we have to mark Q2 Q0 as a final state here. Okay, so we have a starting state. So we have a starting state. We have the final state. We have transitions on all symbols. So in this case, we have to check for transitions from all states on A and B. So look at this. Q0 has a transition on A and B. Q1 has a transition on A and B. Q2, Q0 has a transition on A and on B. And similarly, the dead state is also having it. We have forgot to add the transitions from the dead state itself. So since you look at here, this was present in our table, and we forgot to mark that transition. So the only thing that we need to do here is just mark a transition back to phi upon getting A or B. Okay. Okay, so you also have to do this verification. So once you have created a DFA, you have to check for the starting state, check for the starting state, check for the final state, and also all transitions from all the states. So once you have verified that, then you can declare that you have reached the answer. Okay, so we have done. So this is our answer. So the DFA that you see in green color is our answer. Okay, so we'll work at a few more examples, and then it will become more easier for us. Okay, this is a very simple and epsilon-NFA given here. So let's start converting this into the DFA. So the first step is to take the epsilon closure of Q0, epsilon closure of the given starting state. Okay. So epsilon closure of Q0. Okay, we can identify that epsilon closure of Q0 contains Q0 and Q1 because there is an epsilon transition which goes to Q1. Okay, so this is our epsilon closure of Q0. So our first state is going to be a combination of Q0 and Q1. So we know that from this we can identify that our starting state is going to be Q0, Q1. Okay, now we are going to construct the transition table. Okay. So as you may be aware, the starting state we have identified it as Q0, Q1, and now we want to find the transitions from Q0, Q1. Okay, so what we are now interested in is to find the transition of Q0, Q1 on 0. So for that, I should look at Q0 on 0 as well as Q1 on 0. What about Q0 on 0? Q0 on 0 gets me to Q0 as well as, look at here, there is a path which can be taken like 0 epsilon, which gets me to Q1 as well. Okay, so you can go to Q1 also. So Q0 on 0 will give you Q0 Q1. What about Q1 on 0? Q1 on 0 is not defined. Okay, so all of this combined together will give you Q0 Q1 itself. So Q0 Q1 on 0 goes to Q0 Q1. What about Q0 Q1 on 1? So that will be Q0 on 1 combined with Q1 on 1. Q0 on 1, there is Q0 on 1. So Q0 on 1 can be considered as epsilon 1, right? So it gets me to Q1. What about Q1 on 1? Q1 on 1 also gets me to Q1, right? So combined together again you get Q1. So we'll be getting Q1 here. So from this row only Q1 is a new state for us. So just write the transitions for Q1. Okay. So Q1 on 0. So again we have to look at Q1 on 0. So Q1 on 0, there is nothing defined. If you look at the epsilon-NFA, Q1 on 0 is not defined. So it's actually going to a dead state. What about Q1 on 1? Q1 on 1 is defined to itself. There is nothing more than that. So you can just write Q1 there. Okay, now the only thing that is left out is in this row we are only phi is new to us. So we know that a dead state on any transition goes to dead state itself, right? Now, very importantly, we have to mark the final states. So if you look at the given epsilon-NFA, Q1 is the original final state here. Okay, but when you look at the DFA that you got, okay, Q1 is present both in Q0 Q1 and Q1 itself. So you have to mark both these states as final state. Okay, so that's very important. So Q0 Q1 is also a final state. Q1 and Q0 Q1 both are going to be final states here. So now that we have identified all the transitions, starting state and final states, we can easily draw the DFA. So let's start with the starting state. So our starting state is Q0 Q1. Okay. From there, if you get a 0, you're coming back to Q0 Q1. If you get a 1, you're actually going to Q1. Oh, I missed Q1 here. Okay, so if you get a 1, you're going to Q1. Again, remember, again from Q1, if you're getting a 0, you're going to a dead state. So upon getting a 0 from Q1, you're going to a dead state, which can be indicated by a 5. Now from Q1, if you're getting a 1, you are going to stay at Q1 itself. Okay, so from the transition, it's very clear. And remember, look at the transitions from that state. All the transitions from that state has to go to itself, 0 and 1, right? So this is going to be okay. One more thing, very importantly, we have to double circle the final states. Okay, so Q0 Q1 is a final state since it contains Q1. Similarly, Q1 by itself is also a final state. Okay, so this is going to be our solution. Okay, so again, you can verify this from Q0 Q1. Q0 Q1 is starting state, and from Q0 Q1, transition on 0 is defined. Look at here, transition on 0 is defined. And from Q0 Q1, transition on 1 is defined. From Q1, transition on 1 is defined. Transition on 0 is also defined to here. And in the dead state, transition on 0 and 1 goes to itself. Also, again, remember that you can call these states now with a single letter. So, for example, this particular state can now be called as Q0. This can be called as Q1 itself, right? And this can be called as QD or whatever. So the naming is all completely up to you. So once you got the answer, remember, you should do this only after you're getting a proper answer. So otherwise you will mess it up. Okay. So once you've got an answer, then you can rename it with single letters. You can either follow Q0, Q1, QD, or you can even call them as A, B, C. This state can be called A, this state can be called as B, and this state can be called as D, whatever you like. Okay, so this is something which we have done in our NFA to DFA conversion as well. Okay, so this is something we can do here as well. Okay. Now, as an assignment, you can try this question. Okay, so you are given with an epsilon-NFA, and you have to convert this into an equivalent DFA. So this question will be available in Moodle. The assignment on epsilon-NFA to DFA conversion will be available, and there you have to submit this assignment. So this is just a single assignment. Okay, so I will give you a hint. Okay, so the DFA that you get will contain 4 states. Okay, and out of those, 2 states will be final states. Okay, so with that hint, we'll stop this here.